So the next intermediate reaction intermediate that we are going to treat now is carbon what? Is carbonium ion. Is what? Carbonium a what? Ions. Do you know that I also call it what? Carbon or carbocat ions is another name for what? Carbonium ion. What is carbonium ion? Organic ion. Organic what? Ions which contain a positively charged carbon atom are called carbonium ions. Called what? Carbonium what? Ion. And this carbonium ion, they are usually formed by heterolytic bond fission. Let me add it. They are formed by heterolytic bond fission. This, if you have what? A carbon like this. Let me put H there. Carbon, carbon, and we have Z. And this Z is more electronegative than what? Than carbon. And from this reaction now, we can observe that the bond pair electron here, it will shift to what? To Z. If we shift to Z, we will have the carbon H bond here, then plus Z. So this carbon will become a positive charge, this one will become a negative charge. And the carbon that is forming a negative charge here is what we call what? Carbonium ion. So that is what? How what? Carbonium ion is what? It's formed. And this carbonium ion can be named based on the what? The number of carbon atoms that attach to this what? This functional group carbon. Take for instance now, assume I'm having what? A CH H like this. What did I call this name? You call it what? Methyl carbonium ion. This you call it what? I will call it what? Methyl what? Methyl carbonium ion. This compound, you call it what? Methyl what? Carbonium ion. Good. But in case of we have what? CH3 and CH H plus. What did I go to call this one? I will call it what? Ethyl what? Ethyl carbonium ion. Good. But in case of I'm having this kind of what? Of compound like this, we have, if we have CH3, and we have H here with ions. This one, we call it what? Isopropyl carbonium what? Ion. Iso what? Propyl carbon what? Carbonium ions. So that's how we what? We name a what? Carbonium what? Carbonium ion. Then The next thing is what? Let me explain the formation of what? Of carbonium what? Ion. Yes, formation of carbonium ion. Formation of carbonium, a what? Ion or carbon cation. The carbonium ion can be formed as a result, can be formed in two ways. Whenever the electron withdrawing group is attached to the carbon, it's very easy for the what? For the electron withdrawing group to what? To leave what? The system. And as a result of that, the carbonium ion will form. Let me show you the illustration. For that one, if you have what? Assume we have a key group. This a key bond with X. This X is what? Is halogen group, and is what? Is an electron withdrawing what? Group. So when this X, it is undergo what? Electrolytic friction. This bond here, what? Will shift to what? To X. When the bond shift to X, we are going to have what? A key plus what? Plus X. And the charge of X will be what? Will be negative, and this will be what? Positive. The positive ion that is we have here is what we call what? Carbonium ion. Carbonium what? Ion. Don't forget from the spelling. Organic ions which contain a positive charge carbon atom. Any organic ion that contain a positive charge atom are called carbonium what? Ion or carbon cation. And this, for this I use a key here. Let me use a real what? A real uh, compound. Assume in a compound of what? We have CH3 here, and we have another what? CH3 on top here. We also have CH3 here. Then we have what? Bromine here. So if bromine bond with this reaction, and if this reaction undergo what we call homolytic what? Fission, this bond here will what? Will shift to what? To bromine. When the bond shifts to bromine, we are going to have what? C what? CH3, CH3, CH3. And the charge here will be what? Will be positive, and the bromine will become what? Negative. Abi? So, and this compound, it will call what? Tertiary carbonium what? Carbonium a what? Ion. Can see what? This carbon surrounded with what? Three. How many alkyl group? Three. This is how what? Carbonium ion can what? Can be formed. Let me give you one example of what? Of aromatic. Assume we have a benzene. See, if you have what? A benzene in like this is benzene, and this benzene contains what? CH2, Cl, CH2, Cl, and this one to form a what? A carbon what? Carbon ion. And what happened here? This bond will shift to what? To chlorine. When the bond shifts to chlorine, the benzene will give us what? To give us what? This kind of what? Of structure. Hmm? Yes, we have CH2, abi, plus chlorine, and the chlorine here will become negative what? Negative, and here we have plus. This is what we call what? What is the name of the carbon that is contains what? Uh, I forgot to mention it too. After acylic, a carbon atom that attached to the what? To the benzene are called benzylic carbon. This is what we call what? The what? Benzylic what? Carbonium what? Ion. Yes, this is the name of the what? Of the compound. That's how what? The carbonium ion is what? Is formed. And the next one is two. Carbonium ion can also form when a organic compound it reacts with strong acid. Yes, let me add it. When what organic compound reacts with what? One say also carbonyl ion also generates generated by treating organic what compound with what? With a strong acid. With a strong acid. Let's check it. Whenever a strong acid reacts with what? If we have a compound in this form, we put AA and plus what? Acid. This is strong acid. As a result of that, this will lead to the one we call what? Carbon plus. And we have what? A, we have H. This is what? Carbonium what? Ion. Carbonium, a what? Ions. Or in another site, we can have what? Ethane. If I have what? Ethene, HH, this, ethene, yes, react with what? With bromine. This is bromination, you know, additional reaction, bromine. And this bromine, let's say this bromine carry negative charge. Let me use pen. Let me say what? This bromine carry positive charge. And this one carry what? Negative what? Negative charge. Here like this. And we have what? Uh, HH. Yes, Br here. We have what? H here. On top of this one, we have a what? A positive charge. And this side we have what? H. Hydrogen, we have hydrogen. So the if this is the what? Intermediate product form. The intermediate that form here, a reaction intermediate that is formed here, we call it this is what? Carbon what? Carbonium, a what? Ions. And you know, we have two bromine here. It should mean one. So the second bromine, this is the what in the pathway. I put the second bromine what here. B what? Br my what? Minus. So Br what? Minus. If I put it here, it will now react with what? This Br minus, it will attack in shape to what? So this positive ion here, as a result of that, we are going to have what? The carbon Br here, H, H, carbon H, Br here, B what? H. And the product form here is 1,2 dibromo 1,2 dibromo what? Ethane. So what we need here is what? You can see that what the carbonium form as what? In the reaction inter what? Intermediate. Yes. The next thing or the last thing for today is what? Let me explain the stability of what? Of carbonium ion. So in the next class, I will start from the what? Carbon ion and a carbon free radical. But let me explain the stability of what? Of this carbonium ion. If you look at the stability of carbonium ion, I've already explained it in inductive effect. I've already explained it in a resonant effect. If you, yes, in a resonant effect by using what? Hyperconjugation effect. But let me explain it in case if you miss the previous what? Video. Let us treat the stability of carbonium ion. Stability of carbonium ions. See, the stability of carbonium ion can be influenced by both inductive effects and resonant effects. I mean, the what? Stability of carbonium ion is what? Influenced by both resonance and inductive effects. So the two effects that explain the stability of carbonium ion is what? Resonance effect and the what? Inductive effect. Yes, let me ask you this question. Hmm, hmm. Take this question. Which of these following compounds explain the stability of the following carbonium ion? One, we have CH3, CH2, and CH2 ion. Yes. Mhm. If you look at this compound, his name is what? Carbonium ion. Abi now. And the second one, we have CH2 double bond CH and CH2 double bond. This one we can call it what? Ali carbonium ion. Yes, or allylic what? Carbon what? Carbonium ion. I told you of allylic now. Mm-hmm. And the next one is, let me give you this one aromatic. Mm-hmm. Give you this benzene. Yes, H2. We have plus here. The name of this one, we call it what? Benzyl or benzylic carbonium what? Ion. We call it what? Benzyl what? Or benzylic carbonium ion. You are now asked what? To explain their what? Their stability. The two of them are what? Carbonium ion. And I said the stability of what? Of carbonium ion can be explained by inductive effects and what? And resonance. Have you now? So look at the first one here. The first compound we have is for what? For P CH3, CH2, CH2 plus. Abi, this is what we call what? For what? For P. We call it what? For P carbonium ion. Look at this for P carbonium ion. Abi, it cannot undergo resonance. It cannot undergo what? Resonance. Why? There is no conjugate system. So due to the absence of what? Of resonance effect here, so this compound exists in one form. Abi, or let me say what? It has what? Has no what? Resonance. But compared to what? To allylic carbonium ion, which is what? CH2 double bond H CH3, sorry, CH2 plus. This compound can undergo resonance by shifting this pi bond electron to this side. If we shift it to that side, what are we going to have? We will have what this. This, what does lose pi is become CH2 plus single bond. Here we have what CH, double bond will exist here. We have what CH2. So because of the presence of one resonance structure, this what ionic carbonium ion has, it make him stable than what propyl carbonium ion. For the third one, we have what benzyl carbonium what ion. The benzyl carbonium ion is this. You know what? We have this is benzene, and we have what CH2 here. And on top of what of carbon here we have plus, we call it what benzyl carbonium ion. This is a what? The bond here, the bond here, the bond here. Because this one is what benzyl carbonium ion. This pi bond here have ability to what? To go to this carbon here. So if the bond shifts to what? To the carbon, we have what? We will have CH. This is, sorry, the bond cannot go to the carbon. The bond will go to this side. Sorry, the bond will go to this side to make it true. So when we get there, you have what? Double bond like this. Then we have benzene what? Benzene structure in this form. We have this and we have what? This. So, but don't forget that what? The one that is loose what? The bond here, it will become positive. So, and the next one is this structure. We also, the resonance structure will also increase in this. We have this two, good, and we have what? Single bond here. We have another bond here again. But don't forget that is what? At this end, we have positive, Abi. And this bond now leave to this place and move to this side. When they move to that side, again, the benzene structure will change, come to this side. You have it. This side is lose the what? Does lose its own bond. It also have what? A negative, a positive what? Charge here. Tell you that is what? It has lose what? Bond. And here it has original what bond here, and here we have a double bond CH2. And this double bond we have here will also leave its own place and come to this side. So when the double bond comes to this side, we have what? Reversible reaction. We have the benzene link to sit in this form. We have one, this, and double bond what here? This. So this one that is loose its own pi electron, we have a positive charge here. You can see that is what? The benzyl carbonium ion, the what? This compound, we call it what? Ben what? Ben, am I going to write his name, Jare? Benzylic carbonium what? Carbonium ion. It has how many resonance structure? It has 4 or 5 resonance what? Structure. So the number of resonance structure it has, it's making it to be what? Seriously. It's making it to what? To more stable than what? Than other. In fact, this one is it's not supposed to be there. A mistake. Yeah, there was to be 4. This one and this, they are the same. They are the same. They are the same. Please. It's the same thing with this. Yes. Just like I repeat it. So the allylic carbonium ion has one resonance structure or 2, 1, 2. But this one has what? 4. The benzylic carbonium ion is what? Is more stable than what? Than allylic carbonium ion. Allylic more stable than what? Propyl carbonium ion. And the last one is what? The stability of carbonium ion can also be explained with the aid of what? Electron withdrawing group. Can also be explained by what? Electron. Yes, it's electron releasing. Electron releasing group. What are the electron releasing what? Group. Open bracket plus I what? Effect. The one I explain now is what? You can see that is what? This carbon ion pick electron. They are electron by resonance. So in this aspect, it's just like what? We have a carbon atom that have hydrogen, no, a carbon atom that have alkyl group and alkyl group here. You know, they are releasing electron to the what? To the carbon like this. Abi, and we have what? Carbonium ion here. Another carbon like this, where we have what? Still the secondary carbonium ion, and another carbon we have alkyl H, H, and we have another carbon with what? H, 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 H. You are now asked that what? Which of these is what? Is more stable? I've explained this several times. I use what? Hyperconjugation effect to explain it, and I also use what? In the other application of inductive effects. So the stability of this compound is what? Is this one is more stable than this stable than this stable than this. So this is what? Decrease in what? In stability. The what? Decrease in what? Stability. So that is all about what? Carbonium what? Carbonium ion. So in my next class, I will continue from carbanion and a carbon-free radical. Please don't forget to share our video, to like and comment. Please. Thanks for watching.